Today we have our speaker, Dr. Varun B. Gopi, Assistant Professor at National Institute of Technology, Trichy. Dr. Varun did his PhD in medical image processing, completed a research project titled Development of Efficient Algorithms for Detecting Eye Disease, and has 3 ongoing research projects, currently guiding 7 research scholars. Also has established R&D collaboration national as well as abroad, received Best Paper Award in the year 2012 and Researcher Award in the year 2017. Dr. Varun P. Gopi has published 4 book chapters and has guided 38 PG projects, also organized and conducted technical programs like FTP, STTP conferences, etc. So far delivered 16 invited talks, has published 32 international journals, 28 conference in international and 4 national level conferences. Dr. Varun P. Gopi is a reviewer in 22 reputed and leading journals like IEEE Transactions, IET, IETE, Springer, Elsevier, etc. Today, Dr. Varun will handle a session on Internet of Medical Things. Over to speaker.
Okay, thank you. Is the screen is visible?
Yes, sir. Visible, sir.
Okay, good morning all. So today we are going to see some insights regarding Internet of Medical Things. So as you know, we have some idea, I think you have some idea about Internet of Things. Then what is meant by Internet of Medical Things we will discuss today. So as you know, IoT is coined by Kevin Anston in 1999. According to him, the computers and internet are depend on human beings for information. And the problem is people have limited time, attention, and accuracy, all of which means they are not very good at capturing data about things in the real world. So people may not be ideal for getting all this data, and their time constraint and the accuracy of their acquisition and decision making may be not that much good. So a solution for this is empowering devices to gather accurate, reliable, and timely information on their own. So we call it as Internet of Things, not of humans. So this is proposed by Ashton Kevin. And this is the basic idea behind this IoT. So this in IoT, we have devices which can gather and share information directly with each other and the cloud, making it possible to collect, record, and analyze new data streams faster and more accurately. So because of that, it will result in improved care quality and access in healthcare industry. So mainly this Internet of Things is having a greater application in healthcare department. So that's why we transforming this IoT into Internet of Medical Things. So what are the possibilities of IoT in medical care? So when we starting from e-health to m-health to IOMT in timeline, so we can see this picture where if you start from 1950s, so you can see that on the x-axis you have the years, on y-axis the growth from e-health to m-health, and on the top side we can see that the hardware components trends. So initially the mainframe, also the corresponding networking trends are also there. So hardware trends are there, networking trends are there, year-wise categories are there. So in initial case, we have failed attempt of health data batch processing. So in that time, we couldn't able to process the health data in a batch, and numerous patient information system projects. So numerous patient informations were there. So when we move on to 1960, Technicon, first successful patient information system is developed. And in early days, patient record system, we will keep the normal records in pen and paper. Then in 1970, the telephony-based e-medicine attempt started. So in that time, there is a large-scale massive health data processing happened. Then when we move on to 1980, the health management information systems were developed. And in 19 to 2000, we have e-referencing, e-prescriptions, wireless access to health data, automated alerts, e-health social and learning communities, then web-based e-health applications in administrative, clinical, financial, decision support, expert system, and e-nursing areas. So when we move on to 2010, there are mobile patient monitoring, M-Health. So from e-health, we move on to M-Health. M-Health, social learning and communities, personalized predictive healthcare devices. So nowadays, a lot of predictive healthcare personalized devices are available. Say, for example, the SpO2, that is the saturation measurement device is available, heart rate measurement device are available. So these are point of care personalized devices. Then mobile on demand home healthcare, using your simple mobile phone, Android mobile phone itself, you can use it for healthcare application. Then virtual M hospitals. So you can do the teleconferencing through your phone and you can consult your doctor. So this is the growth of e-health to M-health in the IOMT timeline. And next we move on to IOMT. IOMT will subsume all these e-health technologies. So e-health is the initial one. Then we have telehealth. Then we have M-health and telemedicine. Then remote patient monitoring. And finally, we have mobile patient monitoring. So this is the evolution, starting from e-health to mobile patient monitoring. So now we will see what are the components of IOMT, that is Internet of Medical Things. So first we have a home care unit, and we have communication network, and there is a healthcare tech terminal. So in the home care unit, we have patient data, that is initially image digitizer is there. If you are going to acquire the image, so there should be an image digitizer because we are using all the digital communication techniques for data transmission. So it includes main, auxiliary, and document camera, scanner, etc. Then measurement devices, which includes ECG, blood pressure measurement, and oxygen monitor, that is SpO2 measurement. Then user displays the data to mobile or computer screen. The user can visualize the data at the same time of acquisition. Then there are modems or communication systems to convert the digital data into electrical signal and transmit it through the channel. So in the communication network, we have different networks used for wireless or wired transfer of data. In this, we have data analytics and storage devices. In data analytics, these data analytics process the patient data from receivers, transducers, or for monitoring. And this processing is happening at the cloud level, and you can store it in the storage device in the cloud itself or some other place. And this outcome will be sent to the physician. So in the healthcare terminal, you have a physician. So there you have a physician display used for remote intervention and monitoring. So the information which is known to us through our display can also be available in the physician monitor. So there is a modem which receives the real-time data from network, and physician camera includes main, auxiliary, and document camera because he need to assess your condition and have to reply back to you. So for that, he need all these setups. So this is the whole component of a Internet of Medical Things system. The next is the impact of IOMT. So IOMT increases human-machine interaction, which enhances the real-time health monitoring solutions and patient engagement in decision-making. So there are a lot of machines are connected to the human beings, or we are in touch with different machines. Machine in the sense, a lot of sensors or wearable sensors or actuators or whatever it is. So we are in connection with these machines, and it enhances the real-time health monitoring. So at this time of instant, if you want to take the data of a patient, you can able to get the data because he may be wearing the wearable sensors. So you can easily acquire the data. So by using different operations or different working, still you can give the data to the doctor. So that is the easiness of this IOMT. And here in this case, there is a patient section. So where this patient specific care with context and enabled through past health records. So we have to consider the current scenario and the past history of that concerned patient. Then development of evidence-based guidance which can help to incorporate the local intelligence in future machine. Then we have to improve the inter-device connection and synchronization. Then data-driven health prediction. Then we have to go for real-time tracking and intervention. So initially we are acquiring data and the data acquisition should be perfect. Then it should be transferred to the cloud. In the cloud, we are going to do the predictions. So our algorithms will work on the cloud. So there we will make all the decisions or predictions. After that, we are going to these results to the physician. So he will go through this and he will do the processing and he will tell whether it is correctly find out or not. If there is any correction needed, he will do that. So this is the impact of IOMT. So here the human intervention is very minimal. All the other things are done by means of IoT. So this is the architecture of IOMT. So basically we have three main components. The first one is the local patient systems and controls. So which contain firmware or software, controllers, sensors and actuators, physical systems. And on the other hand, on device connectivity and data management, here we have a database solutions, network devices. And when we move on to analytic solutions, we have servers and cloud solutions, real-time analytics. So we will see each one by one. The first one is the local system and control layer. So in local system and control layer, there is a decentralized intelligence. That means the prime objective is to build a medical device with intelligent control capabilities. So when we are going to design such an IOMT system, first we have to make a decentralized intelligence. That means the main objective is to build a medical device with intelligent control capabilities. So it can control intelligently. So it helps in processing operational data at local level in addition to central server. That means at the device level itself, it is processing in addition to the central server. So some kind of operations this device can perform in the acquisition time itself. Later, the big operations will be transferred to the central server. So this enables with sensors to measure operational parameters, converters to generate digital inputs, controllers to make real-time decision based on input received from converter, and network interfaces to share the data with other machines or central servers. So if you consider the case where you are having a lot more sensors and the data interoperability is required there, then you have to transfer the data between one sensor to another. So these kind of operations are happened inside this data acquisition itself. So at the acquisition level itself, we have a lot of operations to do. In addition to that, we are collecting the data, and if you want to do more processing, we can send this to the central server. Otherwise, most of the operations will be happening at the acquisition itself. So examples of such a device are wearable monitor, implants, and physician handheld diagnostic devices. All these are some of the examples of such kind of local system in the control layer. And next is the compatibility and integration of advanced electronics are additional factors driving the use of IoT solutions to the device level. So once you have a lot of sensors or actuators or any devices to acquire the data, so we have to integrate it properly. Then only you can acquire the data in a proper manner. So, and the second thing, it should be compatible with the standards which we already developed. So the compatibility and integration are the important parts of this local system. And such devices are capable of acquiring qualitative real-time biometric data from patient's body and transmitting it under a secured environment to higher level architecture. So here another problem comes, that is the security, because you are taking the information from a patient and it should securely reach the physician. As you know, if you go for a data set collection, you won't get a data very simply because you need to get a consent from the patient, you need to clear the ethical committee, then only you can use the data set. because it's a very privacy. We are giving privacy to the patient. So in that case, you are taking or you are using a device to take the data from a patient, and you are transmitting it through the physician for processing. So at that time, there may be chance of intruders to collect the data. So in order to make a better and secure communication, you have to consider security in this IoT system. So security is of prime importance in IOMT. Next is the device connectivity and data layer. So this layer primarily focuses on collecting data from the network devices and sorting it in predefined data stores. So once we collected all the data should be arranged in a manner so that the network device can transmit it. So the technologies at this layer are not unique to any solution, such as patient monitoring. So secured medical data transfer technologies manage large data volumes and ensure quality during the process. So say for example, you are acquiring some image data from a patient. As you know, the image data are huge in size. So sometimes you may need to compress the data because your bandwidth is not permitting you to send all the data. So there you are going to do some kind of image compression. So you are doing image compression, but it should not affect the quality of the image. So make sure that the compression algorithm is not reducing the quality of the images. So here the quality is important. And networking firms such as Cisco and Oracle are quite active in providing advanced technologies to end consumers and system integrators based on requirement. So as of now, the Cisco and Oracle are capable of providing us enough space, networking space for this kind of data acquisition and transfer. So we can purchase their cloud so that we can use it. So there they are offering a lot of security in their networks. And the last one is the analytical solution layer. So in the analytical solution layer, irrespective of the type of healthcare solutions enabled, the central remote server collects data from multiple devices over the network and their key components. So whatever the healthcare solutions enabled, this analytic solution layer collects all the data from multiple devices and it acquires the key components. Then server with built-in algorithm analyze real-time operational data to provide insight and conclusion. So once we set up a system, so there we have a lot of algorithms for each and every disease or each and every prediction. So we have different kind of algorithms. So whenever we are giving input to these different algorithms or engines we already designed, that will process the signals in real time, and within few seconds the results will be provided, or it may give a conclusion based on the findings. So that conclusions will be sent to the physician for checking. So this data-driven diligence helps with the diagnostic ability, disease prediction, and implementing preventive measures. Say for example, if one fellow is affected with any kind of cardiac disease, so he may have a wearable sensor. It is clearly measuring the heart rate and the blood pressure and the ejection fraction, that is the left ventricle contraction amount. And for left ventricle contraction, it's around 60% is normal, above 60% is fine, below 60% is a problem. So if we are having an algorithm at the cloud, and we are collecting all the data regarding this, we are transmitting to the cloud, and the cloud, we are analyzing this data, and we found that there is a misalignment or some problem, then definitely we will inform the patient as well as the doctor. Then doctor will look into this and he will make a decision then. So based on that, we can make preventive measures. And the collective and comprehensive evaluation of data from different sources such as implants and smart devices enable healthcare solutions such as remote patient monitoring, interventions, and chronic disease management. So we can collect data from all the sources, and there is a comprehensive evaluation happens at the cloud level, and which can provide a better health solutions such as remote patient monitoring, interventions, and chronic disease management. So using this IOMT architecture, we are able to provide a full health solution to the patients. So this is the 4-layered IOMT healthcare model, where we have a service layer. in service layer, sorry, sensor layer. Initially, we are starting from sensor layer. So here we have a lot of sensors to acquire the data. So after acquiring, it will be transferred to the network layer. There is a router, communication technologies are there. So in the internet layer, then we are having algorithms on this cloud. So where we are processing the information. So after processing information, the information will be passed to the service layer. That means either doctor or nurse, or hospital or emergency team, or patient or ambulance service. So next is progress of IoT. So advances in sensor and connectivity technology allow devices to collect, record, and analyze data that was not accessible before. So in previous cases, what we do is we will go to the doctor, he will initially check for something, then he will ask you to go for some scanning, then later they may get some data from you. Then this process is a kind of sequential one. But advanced sensors are capable of taking multiple data at the same time. So that if one implantable device or a smart device is capable of taking most of the information from human body, so that at the same time we will get more information about a human body, so that we can collect, record, and analyze data in real time. So if we are using a wearable sensor, that will sense the information and send the data to the cloud, and the cloud we can process it at real time, so that the result will be sent to the doctor. So it is happening in real time. So we don't want to wait for any doctor. So it is happening in real time. That is the main advantage of IoT. And in healthcare, sensors can collect and transmit patient data over time. So IoT to help preventive care, to allow early recognition of any complications. Say for example, if you are having a preventive measure system, that means you are wearing some wearable sensors or implants, and you are monitoring your health day by day. So if there is any problem happens, suddenly that will be notified by the system to the concerned fellow, so that he can take preventive measures. So this kind of activities are happening nowadays. And we can monitor how a therapy helps to improve patients' parameters. Say for example, if a person is having paralysis, so we are taking treatment, and in order to study the improvement, we can attach different sensors to his body. So when we get improvement, we can analyze the signal and we can see how the improvement happens and in what time, how much time this fellow is taking to come back to the normal position. So these kind of activities, that is analysis, can also be done using this IoT. And ability of devices to gather data on their own removes the limitation of human entered data. So in normal case, if you go for a data acquisition, so one fellow has to come and attend you, connect the devices, get the data, enter the data, and transmit to the doctor. So here, there is no need of human intervention. So simply, the sensor can take the data and transmit through the system. So it automatically obtaining the data doctors need, and at the time and in the way they need it. So there is another chance of question that how the systems are acquiring the data smartly. So as you know, if you are using a system for acquiring data, it will acquire most of the data from the patient. So, but sometimes we don't want most of the data because some of the data may be redundant. So we can develop devices with smart intelligence so that it can acquire the required signal. And second thing, as I told earlier, some of the devices are acquiring data at the device level, and it processes the signals at the same time. In that case, these systems will do the pre-processing like unwanted noise removal or signal conditioning or the conversion. All those things are happening inside the device level. And the automation reduces the risk of error. So everything is automated, the risk of error is less. And fewer error means increased efficiency. So if the error is reducing means, as you know, we can increase the efficiency and lower the cost and improvements in quality. So if you could develop a good algorithms for the processing, you can improve the quality, and less human intervention is required. So the cost of the system is reduced. And there is a vital need in healthcare where human error can result in morbidity and mortality. So human error may cause morbidity and mortality, but here in using devices, we can clearly monitor each and every time and we can save the patient. So that is the main advantage of IOMT. And here are some of the examples, smartphone ECG transmission. So using smartphone nowadays, we can easily acquire the ECG. And this device can, using the technology, either GSM or any communication standards, you can transmit this data to the cloud. So there in cloud, you have an algorithm to analyze your heartbeat or ECG, and we can make a decision. So nowadays, there are a lot more smart devices and some smartphone apps are available to do this process. Next is smart watches and pebble watches. So I think you people are aware about this. So these watches contains a lot of sensors which acquire the details from human being and it will be transferred to the doctor. If there is any problem happens, definitely that message will be go to the doctor. So the doctor even can send prescriptions, updates, or personalize the messages to individual or groups. If a doctor have a lot of group of people, so all of them are connected through this smartwatches or pebble watches. So definitely he can contact with them through this whenever required. So this is the advancement in IOMT. And next is smart e-bottles and e-pouches. So as you know, so people sometimes forgot to take their medicines. So there are, as a introduction of this IOMT, we have a lot of smart pill bottles are available nowadays. So where these smart pill bottles having intelligence, where it will tell you whether you have taken your medicine on time or if you didn't take the medicine. So information will be sent to your mobile based on the dosage taken or not. So this will definitely help the people to take their medicine in correct time. So this is another advantage of using IOMT. And here the smart bottle have a intelligent system which senses whenever the patient takes this medicine bottle and take the pill from that bottle, he will find that the data or the medicine has been taken, and if he is not taken, he will also detect that and it will be given to the cloud. So from the cloud, you will get the result after processing and you will get a message either you have taken or you haven't taken. So this is the advantage of another IOMT application. And next is medical smartphone. So as you know, nowadays smartphone can be used for a lot of imaging modalities. So for stethoscope, we can use smartphones. Then electrocardiogram, ECG, there are small card-like ECG machines are available. So that can be connected to your mobile phone so that you can visualize the ECG patterns on the mobile. Next is EEG, electroencephalogram. EEG scanning set is available. So we can simply purchase that and you can connect the leads to the head position and you can insert the needle to the smartphone so that you can visualize the brain signals alpha, beta, gamma. These signals can be measured. Then otoscope. Otoscope is the device used to visualize the inside part of human ear. So this otoscope can also be connected with smartphone so that you can visualize the inside part of human ear in your mobile phone. Next one is ophthalmoscope. Ophthalmoscope is a small version of fundus camera. So this is the picture of that ophthalmoscope. So this ophthalmoscope is I think around 59 to 60,000 pricing. So if you purchase that, you can connect iPhone or Android phones to this so that you can visualize the human eye or you can take the fundus images of human eye. Next is imaging using ultrasound and echo. So here also there are a lot of applications are available for mobile phones with ultrasound scanning. So the thing is you need to purchase the scanning transducer. So using that transducer can be connected to the mobile device. So you can take the scan in your phone itself. The next is patient monitoring. So if a patient is connected to different sensors or implants, we can send the data to your mobile phone. So from mobile phone, that will be sent to the cloud. So in cloud, the processing will happen and the result will be sent to both the patient and the doctor. The doctor will look at this result and he will tell if any further action is required. Otherwise, it will be fine. The next is communication aid with device manufacturers. So some specific mobile phones are there, especially meant for such kind of IoT based applications. Or we have to use the software for that purpose for acquiring data and converting it into digital form and transmitting through the cloud. So next is IoT can help us to achieve true patient orientation. So patient orientation is very good because I think you people have visited a lot of hospitals. So doctors are unable to attend all the patients in most of the time. So this kind of online health monitoring will definitely help them to make some real-time analysis because doctors are not available. They can even check the conditions through their mobile phone. So that is very helpful for them. So this defines a seamless information gathering for seamless care and quality in care delivery, like give the right treatment to the right patient because sometimes if they are interpreting something, it may be wrong. So that may take the life of that patient. So with the help of lot of sensors, we can acquire the correct information and we can make a good decision. So at the right time and in the right place, we can make decisions and give remedy regularly and reliably. So if you are connecting a wearable device or implant, so regularly and reliably we can do the diagnosis. And we have not been able to do it till now using traditional paper-based records and communication. In paper-based case, we are not able to do that much regular basis. But when we are moving to this IOMT age, definitely we can assess the condition and we can do the diagnosis in a proper manner, which is far, far better compared to the previous one. The next is IOMT advantages and limitations. So as I told, in every cases, there are some advantages and disadvantages always. So advantages of these IOMT systems are, the first one is patient benefit. So there we have real-time interventions in emergency situation. In emergency situation, real-time interventions can be useful. And the cost reduction, as I told, the number of staffs required is very less here. So manpower amount can be reduced and reduced morbidity and financial burden due to less follow-ups visits. So if you want to consult a doctor, you have to go to hospital. It will have a good amount of cost and your time, everything will be lost. So this will reduce the morbidity. Morbidity means the severeness of disease and financial burden. And healthcare service providers. Next is advantage is healthcare service providers. So optimal utilization of resources and infrastructure. So we can utilize the available resources and infrastructure in an optimal manner and reduce the response time in case of medical emergency. So whenever we have a requirement, definitely we can go for an urgency. So definitely we will be taken into the care. So reduce the response time. We don't want to be in a queue. And device manufacturers, their advantage, the standardization, compatibility, and uniformity of data available. See, one of the advantage of using this IoT device is that, so once we develop a cloud for your data, the patient data can be stored in a centralized cloud where people can access the data, or we can centralize the system so that a common data pool will be available so that people can do research, can access the data, and everything will be a common so that people can get more data. Different hospital can share their data into a common platform so that they can share the whole data with the people, those who are doing research, so that they can use the data, and more number of data will give always more accuracy in decision making when we are using algorithms. So this will help researchers and doctors. And the capability of to sense and communicate health related information to remote location. And another case is if you are in a remote place, there is no hospital facility, there is only a primary health center. Then you have a telemedicine system at the center. You can easily talk to a doctor or consult a doctor in a far distance. So that is one of the advantage of this IOMT. And there are some of limitations. So in limitation, you have technical challenges and market challenges. So if we talk about the technical challenges, security of data, that is the first important thing. So hacking and unauthorized use of IoT. So that is the first problem. Security is not that much good. So hacking may happen and unauthorized use of IoT. Next is lack of standards and communication protocols. If you haven't designed a communication protocol for this, there is a problem. So error in patient handling data. So if any problem happens in storing the data of a patient, so one data is stored in the name of another patient, so there may be issue. So these are some of the challenges. And data integration. So I am taking data from different data from a patient. So I have to integrate it correctly. For this patient ID, I have to integrate it correctly. Otherwise, this may lead to misinterpretation. And need for medical expertise. So this fellow who is doing this operation should also have a medical expertise. And managing device diversity and interoperability. Interoperability in the sense one device, sometimes one device acquiring data that may be transferred to the another device for the second level of acquisition. So that time this interoperability is an important thing. So interoperability is required. And scale, data volume and performance. If you have a patient who is going to be under your consideration from the age of, say, for example, 30 to 60. So 30-year data. So 30-year data you have to store. The scale of amount of data is very huge. So this much data has to be preserved on the cloud. So that become very tight because you need more space to store the data. Such n number of patients will be there. So the data storage and scale is an issue here. Next is market challenges. In physician compliance. So physician compliance in the sense, physicians has to support this. Sometimes if you approach some doctors for this kind of medical support, so they will ask the first question, we are here to diagnose, then what is your role? This is the first question we may face in an engineering point of view. So this is the thinking of most of the doctors. So they are reluctant to adopt the technology, this kind of technology, because they are still afraid of misdiagnosis. So the doctors should accept it and help us. Then only we can improve the health diagnosis using IOMT. Next is data overload or healthcare facility. So as I told earlier, for a hospital, it is quite difficult to handle a single cloud. So the data is overloaded, it may crash the system. Next is mobile hesitation. Some of the mobiles are not supporting such kind of activities. So that is another problem. And security policy compliances. So security is a big issue. So even if you are getting a better secure communication protocol, there is a chance of hacking. So in market is concerned, we have to go for a better secure policy for our IOMT device. Otherwise, we cannot market it properly. Next are some of the concerns and challenges. In concerns and challenges, first one is, as I told, security and privacy. So we are taking data from a patient, that is only his own data. So we have to give privacy to the data and we have to store it securely, and we have to make sure, and we are taking consent from that we are only using this for some dedicated purposes. So we cannot use it for any other purpose, or we cannot sell the data. So we have to make sure that we are providing enough security and privacy to the data which we acquired from the patients. Next, the healthcare reforms and mandates. As you know, the government changes the rules, the healthcare rules. So based on that, we have to change our systems. So that is another challenge. Next is technology adoption. That's what I told earlier. Doctors are reluctant to adopt the technology changes sometimes. So that may have a big impact on this. So we have to convince them. So for that, we have to do a lot of trials. So clinical trials are required. For doing clinical trial itself, we need a help of a doctor. So once it is clinically proven, then only we can go for practical usage. So these three are the main concerns and challenges in this IOMT. And so another challenge is in case of the data. So the average person is likely to generate more than 1 million gigabytes of healthcare related data in their lifetime. So in a equivalent to 300 million books. So this much data is generated from a patient in a lifetime. So you can assume 300 million books of information we are getting from a patient. So this much data digitally we need to record. So this is a real problem. So where we need to store this data. So this is the another challenge. And next is the industry concerns of IoT in healthcare. So first one is the cyber security when using IoT devices. So the security problem. The next is how to use big data collected from IoT devices. Some people may collect data, but they don't know how to process it. So the value of healthcare IoT devices resides in data collection and utilization. So we have to collect it smartly and utilize it properly. So that is the main idea. We have to collect it smartly and utilize it properly. So that we need to we can make sure that we are getting only the required data. So we can call it as data, information, knowledge, wisdom, DIKW. The hospital IT struggles to manage IoT medical devices because of connectivity and seamless flow of information. So there are actions required to improve this IT structure of the hospitals in order to store the data. So there are 5 main drivers of IoT. The first one is the mobile smart technology. As you know, nowadays the mobile can be used for medical diagnosis or for telemedicine or e-medicine. So second is engaged patient and proactive providers. So patients are engaged in their activities and at the same time they can acquire the data using the sensors. And increasing awareness of the value of digital health. So people are nowadays more aware about the digital health. So they are cooperating. So that is driving the IOMT faster. Next is demand for value-based medicine. So if you are correctly analyzed, you can clearly provide a medicine. So depend upon their requirement, they are providing the medicine. So there is no unwanted medicine usage is there. And industries are embracing digital healthcare technology. And approximately 40 million connected devices in IoT and 160 million medical devices in 2018 IOMT. So this is the expected by this 2020, 160 million medical devices. So now we will see some of the applications of IOMT. So in first one is the preventive care is the first example. So in that we have wellness and preventive care, walking, running, swimming. All this is done with the help of implants or wearable devices. So these IOMT devices have facilitated health supervision with the monitoring systems for diet, physical activity, and quality of life. So IOMT enabled devices may be placed on our body. Either it may be an implant or a wearable device. So it can supervise and monitor diet, physical activity, and quality of life. And it can innovative devices such as wearable device or implant chips track continuous data on patient activity and related vital changes. So for a normal person, these data is acquired and if you analyze it may be okay. But if there is any problem with the patient or a problem with a fellow, you can analyze the continuous data and we can predict that. So if there is any anomaly happens, we can indicate that to the patient so that he can take a remedy. And additionally, the remote networking capabilities or capacities of these devices provide expert assistance in emergency situations at any remote location. So all the IOMT devices are especially meant for this remote location operation. So where the doctors are not available. So this will help a remote wellness or preventive care system. And next is chronic disease management. Another application is chronic disease management. So IOMT enabled devices offer promising alternatives to manage chronic morbid disease conditions such as hypertension, cardiac failure, and diabetes. So such devices are used to monitor parameters such as blood pressure, random blood sugar levels, and weight and electrolyte concentrations inside the body. So if you have less electrolytes like sodium or potassium is reduced, you may get unconscious. So you have to go for urgent medical emergency. So if you have a wearable sensor or an implant, these devices will taking care of your hypertension, cardiac failure, or diabetics, or these electrolyte concentrations. So you can easily analyze, and the doctor can easily make a remedy. Or if you are analyzing this for a long time, and if there is any change happens, that is an indication for the incoming disease or incoming sudden problem, so that we can take a remedy before the problem happens. So prevention is better than cure. So in this case, IOMT is providing a prevention here. And next is clinical care. So in clinical care, constantly monitoring physiological status. Say for example, if a patient is affected with heart attack and he is admitted in the hospital in ICU, and he may be connected with a lot of wearable devices and sensors, and every time his health records is monitored. And if the doctor is not available all the time, so he can remotely access the data, and he can check in every time instances through his mobile or through his computer. So this kind of clinical care we can give to the patient through IOMT. And information analysis can also be done. And in the absence of doctor, the system can prescribe something for if there is an urgency. Next is remote patient monitoring. So remote patient monitoring. So here we are having implantable transceiver. So if assume that a person is from remote area, so he is having some disease or any problem, they are implementing one implantable devices into the patient's body. So that implantable device will take the data and pass it through the mobile to the cloud, and it will analyze and send the result to that patient and the doctor can analyze it and tell whether we need to consult him personally or need to go to hospital for further treatment, so that we can do a better decision making. So instead of going randomly to doctor and checking the condition, we can go whenever it's required. And next is remote intervention. So in real-time data obtained from sensor enables physician to administer drug and evaluate a response in case of emergencies. So if you are having some problem, the information is sent to the cloud. From the cloud decides some information and the results are sent to the doctor. So based on the result, doctor will analyze and he will prescribe some drugs in case of some emergency. So you will get the data and you can purchase the drugs and use. Such timely interventions offer high-tech medical assistance and reduce the cost of hospitalization. So there is no need to go to hospital. Doctor will suggest from the other side, you can purchase it and use. And next is improved drug management. So another application is improved drug management. So IoT-based RFID tags managed during drug availability problems and supply cost. So technologies we seen earlier, smart pills or smart pill bottles are there. So technologies have developed edible IoT smart pills which help monitor drug doses and patients' pharmacodynamics. And such solutions may help drug companies mitigate risk and losses during supply chain administration. So this IOMT is helping the drug management also. And other applications are training courses and coaching representations to paramedical staff. Say for example, one doctor is explaining something from one side, the other fellows can listen from other side, and he can do the real operations at one end and he can explain it to the other people on the other side. And next is assistance in rehabilitation and hospitalization. Say for example, if one fellow is affected with some bone crack or something, some bone issues, so he may be taken to hospital. After plastering, he may be taken to home. After the removal of plaster, he may have to go for some physical activities. So in rehabilitation activities, he can take help from the doctor in a remote place. If he's in a remote place, he can take help from the doctor through telemedicine approach or video conferencing. So this is a kind of application IOMT. Next is access to health information electronic records without loss of medical information. And one more thing, so when we acquire the data, so we will definitely insert all the information about the patient. So patient name, patient age, patient health condition, all the information will be embedded on the data set as a header file, so that whenever you require, you can take all the data from that. So there is no loss of information. Next is online protein analysis and accuracy of composition. So we can analyze the online protein analysis using the images. As of now, today there are a lot of image processing algorithms to visualize the protein content in human body. So we can do such kind of activities or researches to do the protein content analysis. So these are some of the applications of IoT. So as a summary, the e-health is based on network ICT devices of humans operated by the humans for the human healthcare and wellness. But on the other hand, we have Internet of Things is the network of smart devices operated by the devices of for the human healthcare and wellness. So in the first case, humans are working for human wellness, but on the other hand, for in IOMT, the network of smart devices operated by the devices acting for human healthcare and wellness. So with this, I will end up my session. So now open to questions. Thank you.
Thank you for your wonderful session, sir. It was really informative and useful. Participants, if you have any queries, you can ask. You can unmute and you can ask, or you can put your queries in the chat box. Participants are kindly requested to fill the attendance form posted in the chat box.
Hello. Hello. Hello.
Yes.
Good afternoon, sir.
Good afternoon.
Related to smart pill.
Hello.
You have shown
Can you message?
architecture of smart pill.
Can you message in
What
the,
capabilities will be required for the smart pill application?
your voice is broken. Can you message in the message box?
I've already given a message.
Okay.
Sir, the question posted in chat box is, what is the type of sensors used for smart pill bottles?
Okay. Okay.
And one more question.
Okay.
What is the frequency specially used for medical data communication?
Okay. So in different, for the second question, different frequencies are used different depend upon the medical modalities. So if you go for MRI images, it's in the range of 10 raised to 7 to 10 raised to 10 megahertz. And when we move on to, we are utilizing most of the signal frequencies. So for visible light, we are having endoscopy and OCT and fundus. And then infrared thermal cameras are there. The infrared frequency is used for thermal cameras, and CT and X-rays, we are using high frequency in the range of 10 raised to 70 to 10 raised to 20. So these are very high frequency, but as of better human health is concerned, the frequency less than 10 raised to 10 gigahertz is fine. So we are having a good communication standard if you go for a frequency less than 10 gigahertz. And the smart spills, we have different kind of sensors. I don't know exactly what kind of sensors they are using, but there are a lot of MEMS-based sensors we are using. So micro electromechanical device sensors are used, MEMS sensors.
Thank you, Varun sir, for your presentation.
Okay, thank you. Okay, may I leave?
Yes, sir. Yes, sir. Thank you, sir. Thanks a lot.
Thank you all. Thank you, Triple IT, Trichy, for inviting me for a talk. And I would like to thank all the participants for your time and patience. Thank you.
Participants are requested to fill the attendance form posted in the chat box. Next session starts by 11:30.